So hello and welcome to Current Thinking, Eaton's new broadcast series looking at issues and trends shaping the world of electrical innovation. My name is Thomas Dimitrovich, Vice President of Technical Sales with Eaton's Busman Division. Today with me I have two industry experts, both of which sit on code-making panels and help usher in the new changes with regard to the National Electrical Code. So David and Larry Eyre. So David, why don't you just introduce yourself?
Hi, my name is Dave Williams. I'm an electrical inspector in Delta Township in Lansing, Michigan. I've been in the electrical industry for 45 years. I'm a master electrician. I represent the International Association of Electrical Inspectors on panel 5 for a few cycles. I chaired panel 7 for the 17th cycle. And for the current cycle, the 2020, I served on panel 10, as well as on the NEC Correlating Committee.
Hi, my name is Larry Eyre, and I am Vice President of Viscom Electric in Cincinnati, Ohio, and I'm also a registered professional engineer in approximately 9 states. I represent independent electrical contractors on various technical committees for the National Fire Protection Association. I sit on Code-Making Panel 13, which deals with generators, batteries, and life safety systems. I also sit on NFPA 70E, which is the electrical safety standard in the workplace. I am currently chair of the NEC Correlating Committee.
Awesome. Well, I appreciate it. Thanks for both of you for being here. And we're going to talk a lot about the National Electrical Code, but before we get into some of the latest changes that occurred in the NEC, I'd love to have a discussion just around how those changes come about, because I know that there's a process that NFPA uses to bring a lot of individuals together, experts like us from a code panel perspective, and we review public input. So Larry, why don't you talk a little bit about that process and how we introduce changes to the NEC?
It's kind of a neat process where in this country, a lot of things are done by the consensus process, by a lot of volunteers that get together and decide on what is the best avenue and to move forward. Basically, the way I look at things, it's kind of a 3-legged stool. You have inputs, comments, and appeals. And so if you look at that, anybody can submit a public comment or a public input, and that is maybe that public input is driven by maybe something that happened, a fatality or an injury, or maybe it's a new technology. That public input may be something that was simple as someone wanted to correct some grammar because they didn't understand something. So once you submit something and you submit it to a panel, they can either look at it and say, yes, I like it, maybe they modify it, or maybe they reject it outright. Then you go on to the next stage, which is the comment stage, and someone might say, okay, hey, I didn't like what you did, but I want to submit a comment to either revise what you did, or can you the thing that you maybe rejected, can you bring it back, and so can we look at it again? And then finally you go to the last process, which is appeals. So if you really didn't get anything in the first 2 stages, you can go to the appeals. Either you appeal to the annual National Fire Protection Association annual meeting to the entire body, or you can appeal to the governing body of NFPA, which is called the Standards Council. So it is a 3 or 4-step process. So sometimes it's a little bit difficult sometimes to change the code.
You mentioned about anybody can make a public input, and then all of those public inputs are available or reviewed by the code panels. I know you had a good example.
It was in the 1996 code. The code panel changed to require a separate 20-amp circuit for all the bathroom receptacles and dwelling units. And probably about maybe 6 or 8 months later after it was adopted, I had a homeowner that went there for a re-inspection, and she complained about the circuit breakers were tripping in her bathrooms when she was blowing her hair in her bathroom and her daughter was doing the same in the other bathrooms. I said, well, that's doing what it's supposed to do. She said, well, every bathroom should have its own circuit. I said, well, you can submit a proposal to make that change if you want to. And I gave her the form, she filled it out, and I do remember seeing panel 2 discussed it, but it didn't pass. But anybody can get involved in the process. And I would encourage anybody to submit a change, because we're code panel members and we see the issues that come in, but we don't have all the answers and we don't see everything. Yeah. And also, I think it's important for those in the industry that are out there submitting changes to look at why the code's changed, and that documentation is available on the NFPA website to let them know why that change actually occurred.
Yeah, so you and Larry had mentioned that safety, examples of where we can improve safety and whether injury or damage or to electrical equipment or personnel. What about the other reasons? Like, I know from an inspector's perspective, David, you have to enforce it, right? And usability, I think, is an important topic on why you might see change in the National Electrical Code. So is that, how does that, can you just elaborate a little bit on the usability aspect of it?
I think it's important, we have code changes or code requirements out there, and it's important that we get the proper input from those that are out there that are either enforcing the code, trying to make sure it's complied with based on the wording that's there, and you also have installers that are trying to comply with the code. And if there's an issue out there, the code panels really want to hear from you, because you guys are the eyes and the ears and the knowledge of what actually is taking place. There's other people that, aren't out there seeing all the issues that installers and enforcers are actually seeing.
Yeah, so the NFPA, which is the National Fire Protection Association, they own this process. Who sits at the table? Is it manufacturers? Is it all installers? I mean, is there a defined criteria for the mix? And who makes those decisions, Larry?
It's made up of a variety of people. I mean, you have people that come from the Engineering Society, IEEE. You have people that maybe come from heavy industrial. You have people that represent NEMA, which is the National Electrical Manufacturers Association. And then you have installer maintainers, people that represent NECA, National Electrical Contract Association, or Independent Electrical Contract Association. You might have labor from International Brotherhood of Electrical Workers. So you have a variety of people, and you also have people that represent themselves. So you typically try to get a cross-reference or a cross-section of people so they can sit at the table and discuss these issues with the least amount of bias.
That brings a lot of perspective in, because an inspector may have a different perspective. Say, I don't like that language because I can't enforce it.
And one thing that's always important to remember, that the NEC or the NFPA process doesn't allow one interest group to have any controlling interest to make changes. I've heard over the years that a lot of changes are based on what the manufacturers want, and that's really not the case. I mean, I think I've seen more changes in the code that require the manufacturers to change more so than the other way around.
Yeah, and as we get into some of these changes, we'll show how
we definitely have a few of those.
Yes, that where the code requirement drove a standard change, and then we have to put some delays because we don't have a solution, and we need to make a change, which leads us into, I think, the next part of this discussion, which is around some of the key changes in the National Electrical Code. And I think the very first area of discussion, in my opinion, is service entrance equipment is probably arguably the area of the power distribution system that safety is of a really important concern. So let's have a little bit of a discussion on that, Dave, if you want to lead us off, because Code Making Panel 10 covers Article 230 for the service entrance equipment. So why don't you lead us off in that discussion? Well,
in the previous cycles of the code, Article 225, which deals with outside branch circuits and feeders, and Article 230, dealing with services, was under Panel 4. Panel 4 is mostly alternative energy, and they have a pretty large workload as it is, so they gave those two articles to Panel 10 to work on. So in this cycle of the code, Panel 10 has the responsibility for services. And I don't know if it's because we have a new perspective looking at those changes, we see a lot more changes in this cycle in Article 230. One of the biggest changes that we have in this cycle is the requirement for an emergency disconnect outside of every 1 and 2 family dwelling. And this originally started in the 17 code cycle at the NFPA annual meeting, that it didn't gain enough traction to be put into the 17 code. But the code panel received a similar public input this time for it was called a firefighter's disconnect. And it was designed so when you have firemen, in case of a house fire or stuff, they need to be able to work on that safely and not to be worried about the electrical power that's in this building that could cause additional harm or impede them in putting out the fire. And so having an outside emergency disconnect for that was a great idea. And the Home Builders Association came to our code panel and discussed it, and they were in total support for this change. But the only thing that they suggested, that they change the term from firefighter to emergency disconnect. And I kept wondering, what's the reason for that? And they elaborated a little bit that you may have other people that would need to turn that disconnect off. You may have a good example, just if we had a small house fire and you live in that house, the first thing we want you to do is to get out of that house safely. We don't want you to go down and find your electrical panel and turn the breakers off and then try to get out. We wanted to get you out of there. So then they could always go out and turn that emergency disconnect off and turn off all the power to the house by that. So that's a good option. And also you may have a gas company, you may have a gas leak, and it would allow them to turn off that disconnect. If it was called firefighter disconnect, there was a concern that some people would think that it was only for the fire department to use, and that wasn't the intent. And we've seen this used in other parts of the country as a requirement already, such as like the Southeast and the Southwest have already had this requirement to have an emergency disconnect on the outside of the house. So it's not a change for some people, but for a lot of areas of the country, it will be a big change.
Yeah. So now we're still at the service, and to your point, I can turn power off, right? Now the electrical worker, there was another recent change, and I know this resonates, I think, well with 70E from a safety perspective. The 6 disconnect rule changed. I'm not sure. Do you want to start us off, and then David can kick in on the 6 disconnect rule changes?
Sure. I think that over time, what you're seeing is that 70E, which is the document that provides the electrical safety in the workplace across the country, that document has really taken off. Really done a great job over the last. It started in basically I think 1979, and it's a very popular document today. And what you're seeing is a lot of the things that came out of that document are making their way into the National Electric Code. And we're trying to find ways to reduce the possibility of a shock hazard. We're trying to reduce the possibility of an arc flash hazard. And so one of the things that you're seeing is that the 6 disconnect rule is still there, but now it is, how do you have the 6 disconnect rule? Are you allowed to have 6 disconnects within an enclosure, or do you have to separate them? And so that's the new requirements in 230.71, is that you must have, if you're going to have 6 disconnects, you must have them in separate enclosures, or you must have barriers in between them, like if you're doing a switchboard. And part of that reason, again, is to make sure that we maintain, we reduce the shock hazard, and we reduce any possibility of arc flash hazard on the line side of where the service comes in. And I think you mentioned it in one of your opening statements here in this topic, is that one of the most dangerous parts of any electrical system is where the power comes into the service.
So David, wasn't there already a requirement for line side barriers somewhere else in the NEC?
Yeah, in 408.3 for panel boards, there was a provision that required for service conductors in panel boards and switchboards that you had to have a barrier on the line terminations or where the service terminations were at. And by moving it, and with that, if you turn the main breaker off, there should be no live parts in that building or in that enclosure. By moving it to Article 230 for services, it's more of a natural home. And also by moving it, it now includes other things that were not covered in Article 408 for panel boards and switchboards. So if you have like just a service disconnect that's service rated, now that would be included as well because it's in Article 230. And that's, to me, where it should be.
Yeah, it really shows you how the code can drive standards, because all of those products are going to have that change, and that's really driving UL standards as well. So let's shift gears a little bit, but we're still going to be at the service entrance equipment. Another big change, I think, that hit the streets is a requirement around surge protection. That's your article.
Yes. Well, in the previous code cycles, we had Articles 280 for surge arresters and 285 for surge protected devices. Those were merged in the 2020 code cycle and given to Panel 10. And now it's called Article 242 for overvoltage protection, which includes surge arresters and surge protected devices. A surge protected device is designed to limit surges on your electrical system by diverting the energy or eliminating the energy or the high voltage surges that you may have to protect our electronic components that we have in our systems. You know, there were actually 2 public inputs to add surge protection, and actually it was for every building, not just dwelling units. But the code panel limited it to dwelling units in this cycle. And there may be something that may happen later on in the next code cycle, that it may progress further. From the 17 code cycle, there was a number of articles that added surge protection for elevators in Article 620, Article 645 dealing with critical operations data systems, elevators in Article 620.
And Article 700 too.
And 695 for fire pumps, as well as in Article 700 for emergency systems. So surge protection has made a huge increase in the last few code cycles. You know, besides all of our appliances that we have, and you know, years ago I never bought a warranty on an appliance because I didn't think it was worth it. But now, with all the electronics in there, one small surge and you've lost your appliance, and you really need those. Yeah. And very good reason to have surge protection. But I think what pushed the panel in this code cycle was the fact that all of our life-saving devices, such as our smoke alarms, I mean, they warn us to get out of the house in case of a smoke or fire condition. We have carbon monoxide alarms. We have our ground fault circuit interrupters, our GFCIs, and AFCIs, our arc fault circuit interrupters. Those are life-saving devices, and if we have a surge, there's a good chance they may not be there if we need them. Yeah. So I think it's a great change. In fact, one of my last inspections before coming here was a house doing an inspection for something else, and the lady was telling me about that her furnace got fried because of a surge. And I explained to her about the new change that's coming in the 2020 code, and she says, that's a good thing. It's needed, because it would have saved a lot of problems that she's had. And I'm sure everybody else has experienced similar issues as well.
Yeah, it's all about persons and property. So National Electrical Code there's to protect a lot more than just us. So now you mentioned that the surge protective devices are there to protect things like GFCIs, right? Which leads us into, I know, ground fault circuit interrupters.
Can I interrupt you real quick?
Yeah.
What I failed to mention regarding the surge protection, again, it's required to be for 1 and 2 family dwellings at the service panel, and it requires either a type 1 or a type 2. A type 1 would be ahead of the service overcurrent device, and a type 2 would be on the load side. With most surge protection, you're normally going to see like a 2-pole breaker feeding the surge protected device, a type 2 protected device, and that would provide the protection. Another thing that the code panel did in this cycle, they made it very clear that if you replace that service panel, you need to add surge protection as well. It was kind of a given just by the way things are worded normally, because if you're installing a new service, well, the code says we need surge protection for services, but they went the extra mile and says replacements also need surge protection. So that was a big change.
Yeah, absolutely. That's really, and again, it's there to protect life-saving devices like GFCIs, AFCIs, and other things. So let's talk about GFCIs, ground fault circuit interrupters. Those saw some change over the last 2 cycles, I think, that are big. But you know, they presented some correlating issues and whatnot. And so David, why don't you kick us off on that, and
okay.
then I'd like to hear from Larry on the correlation issues.
GFCIs, or ground fault circuit interrupters, are a device that they protect us from shocks and electrocutions. Once the voltage gets to a certain point, or the current of between 4 to 6 milliamps, it would trip or turn off the circuit to that area and keep people from being shocked or electrocuted. GFCIs first came about in the 1971 code cycle, and for the most of the time it was based on dwelling unit applications only. And over a period of years, we're starting to see more and more requirements come into the code for other than dwelling units, such as commercial buildings. And it's a big change. And
yeah, because it went to a higher current value. So later on, you know, that higher current value created some conflicts, I think, with other areas of the NEC.
Right, and I think what's happened is it's always been 125 volt, 15 and 20 ampere. Right. And now, because of new products that have come out, new technologies have allowed us to make GFCIs for higher ampacities. It's also allowed us to make GFCIs for three-phase circuits, which normally they weren't available. And so now what's happened is 210.8 has mandated GFCIs in a whole host of regions or areas inside and outside the home and outside in general. And so what happens is up in some of the other chapters in the code, we talked about chapters 1 through 4 applied generally, and 5 through 7 can modify anything from 1 through 7. And so what happens is in some of those articles, for instance, Article 547 for agricultural buildings, maybe 550 for mobile homes, and 551 for RVs, there are special requirements that they weren't set up to put GFCIs up for the higher ampacities, and so they modify some of the things in 210.8. And so over time there becomes some conflict, and maybe some things weren't written properly, and maybe there gets confusion between what happened in 210 and what happens in those higher articles. And so the Correlating Committee put together a little task group to make sure that the wording in there is clear and usable to the user of the code.
So David, so you have, to your point, you have these other areas in the code where we have GFCI requirements, right? And it was 15 and 20, and we increased the amp value. So, but why did we have to increase? Why did we go beyond 15 and 20? What were some of the driving factors in 210.8, some of the expansion from a higher current value perspective?
There's a lot of loads out there that, a good example, there was a fatality or a public input because of a fatality where kids were playing hide and seek in a house with behind the electric clothes dryer, which is a 240 volt load, which normally it would never have had to be GFI protected. But again, unfortunately, fatalities are a reason we see a number of changes that affect safety. And we had a similar one regarding air conditioning units. There was an individual that was electrocuted on a central air condensing unit that was outside. You know, when GFCIs first came in the 1971 code, everybody asked, how many lives is this going to save? And we had no knowledge, or you couldn't put a price tag on what it's going to save. And I think at that time there were about 800 electrocutions a year, and now it's down to about 100 a year. So they definitely do their job. And again, another reason we need that surge protection on those.
Yeah, absolutely. Now, you know, whenever I talk about the trends, the downward trends in electrocutions, we can't forget the fact that since the 70s and 60s, we've changed a lot in our industry. We've provided GFCIs. We've changed. You can't get metal drills anymore. They have plastic handles. We have provisions to protect extension cords and things of that nature. So our industry has changed, and we have an education perspective, right? And shock and the hazards of electricity from electrocutions. I think we're raising the awareness, and in addition to providing the levels of protection. So, and I think that'll probably continue to expand as we move forward throughout the future of the NEC. But so let's talk. Let's shift gears a little bit. We have the GFCI requirements. We talked about the service entrance. Now, another set of requirements in the code that impact the services in an indirect manner are load calculations. And I know, Larry, you chaired a committee around Article 220 load calculations. So why don't you share a little bit of what you...
You know, I look at this as an important thing that happened in the 2020 code. You know, some of these things in the code change really fast, and some of them really change slow. And I think the load calculations is one that it took some time. You know, if we go back to 1950, you know, we talk about there was a lot of incandescent light bulbs and things like that, and there was unit loads that were put in Table 220.12 that helped us size services for the lighting portion of the building. And you know, for instance, in the office environment, those used to be 5 watts per square foot, and that's how we calculated what we needed. In 1980, when we start getting more and more fluorescent lighting and things of that, and as that got improved, we made a change down to 3 watts. And it's been there for 40 years. And so finally, with the advent of LED lighting and all this new technology that's come out, you know, services kind of become oversized to some degree, and people have always tried to figure out how to reduce those service size and those load calculations. And I think one of the neat things that we did in this last cycle is that we tried to be progressive into the NEC. We tried to kind of mirror the language, the Table 220.12 that talks about rooms and what room names are. We took that and we kind of looked at ASHRAE 90.1, and we updated our nomenclature on how we talk about occupancies, and we severely reduced the lighting loads. So you think from the 50s, we went from 5 watts, to the 80s, we went to 3 watts, and now in 2020, we're going to go to 1.3 watts for just office buildings. And now most every category has been changed. But in some categories, what's funny is that over time, hospitals are not the same that they're not used the same way they were used 30 years ago. So some have increased, some have went down, but we adopted the ASHRAE 90.1 2000 version. So people might say, well, why didn't you make it more current? We wanted to have some safety factors in there. We wanted to make sure that not everybody adopts the code on a regular basis. So we all came to a consensus agreement on the ASHRAE 2000. And with the hope that as time goes on, that we can move forward. We have a benchmark, and we have a path to change to future editions of ASHRAE as time goes on.
Yeah, so you made a change to 220.12, the table, and you have all of the occupancy types that now align with Article 90.1, but what about residential?
Well, residential also, I don't think was ever part of ASHRAE 91, so we moved it out of there. So we moved it to its own separate category. So you still have to, do residential calculations at 3 watts per square foot. So we tried to take 220.12 and make that strictly a commercial table.
Yeah. So what happens if when I look at 220.12 and I'm familiar with armories or I'm familiar with a gymnasium? That's the terminology I use now. It's changed.
Well, what we did was we took some of those old terminologies and we put them on the bottom in notes to the table. So that way our goal is for maybe one cycle to educate people so they know what those old terminologies really are now. Okay. And so we had a cross-reference with the hope that someday that those notes will go away. Yeah. But we tried to make it user-friendly so people had a path to follow what we did.
Cool. All right, so let's move a little bit to reconditioned equipment, because if I think about all of the different changes in the National Electrical Code, reconditioned equipment was pretty controversial. It made it all its way. In our earlier discussion, we talked about the process. There were appeals made to Standards Council on this topic. So I know, David, I know the definition resides in Panel 10, and you probably are close to this topic. So,
yeah, reconditioned equipment originally was in the 2017 code, which made the requirement for reconditioned equipment. They added a definition in the 2020 code cycle. It was originally crafted by Panel 9, but the coordinating committee gave the purview to that definition to Panel 10. And that's because Panel 10 has equipment under their purview that is required to be reconditioned, is permitted to be reconditioned, and also equipment that is not permitted to be reconditioned, such as the circuit breakers that we have in our homes. Our molded case circuit breakers, those are not permitted to be reconditioned. But then you have low voltage and medium voltage circuit breakers, and those are permitted to be reconditioned. So that was part of the reason why it went to Panel 10. With the requirements for reconditioning, there's the new definition, but in that definition it also includes what is other terms that may be similar. They reference rebuilt, which is kind of what I think the testing laboratories use. They also reference refurbished or remanufactured. But it's still all considered as reconditioned equipment, because we have a lot of equipment that is out there that is old and needs to be replaced or in bad shape, and they don't make it anymore. So it allows a company to ship that equipment out, have it reconditioned and brought back in. The code requirement does require that they put a label on there showing who did the reconditioning, when the reconditioning occurred, and there was another thing,
the label
and
the UL label. They removed the UL listing, yeah.
To require them to remove the listing mark, the original listing mark on that piece of equipment, because the reconditioning does not require it to comply with the original listing of that original manufacturing of that piece of equipment.
Yeah, and I think that was really a part of the most contentious parts of everything, because removing of the UL listing mark, right? There's requirements on some products that it has to be listed when you install it, and the fear is, well, I'm going to have to relist it, or I'll have to get a third-party review it, and that third-party review adds some value, right? I mean, as an inspector, when you're looking at something that was modified in the field, how do you know whether or not it's okay?
You know, as an AHJ, I think most of us rely very heavily on the UL listing, or not UL listing, but a listing of any nationally recognized testing laboratory, or NERDLs for short. And there's probably about 16, if I had to guess, around 16 of them in the United States and Canada as well. And without them being able to provide that listing on the products, I don't know how comfortable I would be to accept a lot of equipment. Because, I mean, just a GFCI device alone, there's like about 15 or 16 different standards that go into that. And when you get to some of this large switchgear that we have like behind us, I can't imagine how many different standards go into the manufacturing of that piece of equipment. And as an inspector, I know I don't want to even go there. So we rely heavily on the product listing for those installations.
Right. And I think it all hinges on the discussion or the understanding of the definition. Like, for example, Larry, if I took a circuit breaker out of a panel board and put it into another panel board, is that reconditioning the panel board or the circuit breaker? Just reusing. You know, I can reuse equipment, but that doesn't meet the definition, because the definition says, what does it say? It says you're taking it from a non-working condition, putting it into a working condition.
And I think that's part of the thing that happened is that the correlating committee asked all of these panels. Yep. They had a definition for reconditioning equipment, but what equipment can you recondition? And so the correlating committee asked each panel to go through their articles and say, tell us what you can and can't recondition. And I think that's created a little heartburn, but at least now know some people say, okay, I can't recondition motor circuit breakers. I can recondition certain parts of switchgear. And so I think it's helped provide some clarity.
Yeah. So now, yeah, go ahead.
With that requirement alone, how does an AHJ know that piece of equipment is permitted to be reconditioned or not? We have code requirements that tell us that now. That's right. Before, it was the wild, wild west. It was up to the inspector saying, should he accept the reconditioned equipment or not? Now we've got some documentation or code requirements that can back us up to require it.
And all of these requirements, the National Electrical Code, NFPA 70B on maintenance, right? All of those work together, including 70E around electrical safety. And when I think of electrical safety, I think of 70E, and we talked a little bit about the arc flash and incident energy with regard to some of the service entrance changes, right, and the line side barriers. Another section of the code, or two sections of the code that I think of, are 24087 for circuit breakers and arc reduction requirements, and 24067 for fuses and arc reduction. So Larry, I know you're closest from a design engineering perspective, and you're on 70E from an incident energy perspective. Can you elaborate a little bit more on some of the changes that we saw in 2020 with regard to those two sections?
Yeah, and you know what's interesting, this is another topic where, as we discussed, 70E and the safety across the country, and energized work and shock and arc flash, it's another area where it's starting to make more headway into the code. And so we're looking at the fact that we're trying to reduce shock hazards, we're trying to reduce incident energy. And incident energy is the amount of heat that could come up out to a person's chest should an arc flash event occur. And so what happened in 2011 was 240.87, and 240.87 required breakers, overcurrent devices above 1200 amps to have some sort of arc energy reduction. And subsequently in 2017, that led to 240.67, which was arc energy reduction for fuses. And so you have to do certain things to make sure you reduce the energy. So if someone was to work on equipment downstream of that device, the energy is lower. And so in the most recent section, 2020, there is now requirements similar to testing of ground fault protection equipment. Now you have to have some sort of arc energy reduction testing, and you have to demonstrate that to the AHJ that you did that and you tested it. Yeah. So all these things combined, if you look at it, the maintenance standard, 70B, the electrical safety standard, 70E, and the NEC are all kind of merging over time, and they're becoming very important.
Yeah, so the 2020 version of 24087, for example, is telling us that we have to know the arcing current. We have to make sure that whatever the method in 24087B, because that's the methods that we use, whatever method has to operate based on the arcing currents, right? So But the big change, I think, in 248.7 was around the performance testing.
Oh, there's no doubt about that. And so, but what you also see too is the terminology just used, arcing current. Sometimes these things here, these are very technical things that sometimes the contractor is maybe not trained on, and he has to look to people like Eaton to help him out to make sure that he selects the proper breaker. He selects the breaker that is within the instantaneous region for the arcing current. So sometimes you have to work hand in hand with the manufacturer or other people to try to solve some of these issues.
Right, yeah. And we rely on the overcurrent. So when we talk about refurbished condition, reconditioned equipment, refurbished equipment, reconditioned equipment, we're relying on the overcurrent protective device to do its job, right? And so, and 240.87 changes and 67, where we have to do the performance testing, aligns with 230.95. And again, panel 10 is just rocking the house there, right? So they're really focused on safety.
It was a pretty busy code cycle.
It sure was. I mean, you realize you changed a lot of what we do in the industry, what we've done since the 70s. We did the 2020 code changes. We changed the 6 disconnect rule, modified that. We've increased GFCIs. We're addressing correlating issues on between later code panels. It was a big change from an NEC perspective.
And surge, yeah.
Yeah, and all the technology, like you said, on the load calculations, we're looking at new technology. So if you think about moving forward in the 2023 and beyond, I know, Larry, you're the coordinating committee chair, and I know you've already started working on the next version of the National Electrical Code. So why don't you share a little bit about what's on the horizon?
Yeah, and as soon as the 2020s, the ink's dry, you really start on the next cycle, and you start to think, because you only have probably about a year or so before you really have to start submitting public inputs for the next cycle. And one of the things that I think is concerning is that we are getting the technology is moving pretty fast. We have new HVAC technologies. We have new LED lighting. We have all these different things. We have people are starting to wire stuff that, like refrigerators, that they're starting to wire them with computer cables. And so these new technologies, we have to be able to regulate them to some extent, and we also have to put them into the code into a usable format so someone can understand. And so what we're trying to do is, if you think back since the code was first started in the 1890s, is that it was really set up for just 120 and 240 volt. It really wasn't set up for medium voltage and some of these other technologies. And so we are looking out to put groups together to study medium voltage. How best can we relay the information on medium voltage to the code and to the user? Alternative energy is becoming huge. The requirements maybe out in California, where they require you to have 33% of your energy come from renewable by 2030. There's a lot of things coming down the pike. And so we have to make sure that we explain that and put regulations in there in the most usable and clear format.
But wait a second, medium voltage is utility. Why is the NEC messing with medium voltage?
Well, what's happening is over time is that the utility, a lot of the medium voltage might be microgrids, where the microgrids are not the utility. They disconnect from the utility. And then inspectors have to inspect those things. And so that medium voltage is changing from what it used to be. Right. It's not strictly the utility anymore. And we also have things where we have a lot of things that are happening in the low voltage arena, or limited energy, where we have power over Ethernet. People wiring things from network switches, lighting, for instance. There are whole buildings that are wiring their lighting from the output of network switches, and we have things now that we are doing pulse DC, wiring stuff on computer cables. And so we have to try to put this in the code into the most usable and clear format, and we have to look at this.
So you had mentioned earlier about where you're talking about industry changing. Well, what about healthcare? I know healthcare is going through, that entire industry is going from big hospitals that we all go to now to smaller facilities and maybe even doing things at home. What's going on in that area?
Yeah, and there's another thing that's coming down the pike that we just put together is things for durable medical equipment. You think about it, more and more people are doing healthcare at home. Maybe it's dialysis, maybe it's oxygen, things like that. There's a lot of outpatient stuff where people go home to do their own treatment, or in-home nursing. And so a perfect example of some of the things that happened out in the wildfires out in California. where people lose their power for 5 days. How does that correspond for people having health care at home and maybe they need emergency power? And so we're putting together a group to study those things to make sure that we have the proper requirements for those needs.
Yeah, so we got industry changing, we have technology changing. So as an industry, we have to keep up with all of that, right? And David, I know you're a part of the International Association of Electrical Inspectors and the IEI, and we all have our organizations, but I know how we met. We met at an IEI meeting and doing presentations, and we argue and we debate about National Electrical Code requirements and things of that nature. So can you elaborate a little bit more on how does the electrical industry, how do we keep everybody up to date with what's going on?
Changes are going to happen. We need to be prepared. And the best way to be prepared is to be educated. And the IEI does a great job. One thing nice that's unique about the IEI, it brings all these other industry groups together at the same table. You bring the union workers, the non-union workers, you bring contractors, engineers, architects, and inspectors all together and discuss the code or debate the code or discuss proposals or public inputs or changes that occur. And it's a great avenue for a lot of installation, for a lot of the industry to come together. One thing that the IEI is doing, they are having a new program now that making all student members have free membership. And they're going to have an app that they can get the information up in there. They have a nice magazine that will be available. And it would allow for any student member, whether they're through a vocational program, an apprenticeship program, or wherever.
Yeah, so you have organizations like the International Association of Electrical Inspectors. So, as a contractor, you have to prepare for these changes. I mean, do you leverage? I mean, how do you prepare? I mean, from a
it is kind of tag teaming on that IEI. They really do a good job, and I think it's also important for a contractor to go to their meetings, to listen to what they have to say, because those are ultimately the inspectors that are inspecting our work, and we want to know what they're thinking, how they interpret the code. And so I went to the Western Section meeting recently back in September, and great meeting. They produce great educational material. There's other organizations out there too. I belong to Independent Electrical Contractors. There's National Electrical Contract Association. There's the Institute for Electronic and Electrical Engineers. All of these associations produce webinars. They produce white papers and things like that. You can find stuff on YouTube. There's all kind of avenues for you to learn, and I think it's important that contractors use those resources. And what we're doing today, manufacturers do these things, and I think it's important that we use those resources to keep up, because like we've discussed here today, things are moving pretty fast.
Yeah, technology is growing and changing, and staying on top of things is I think is one critical aspect of keeping things safe and whatnot. So,
I remember hearing one comment at one of our meetings, and one of the contractors say it's nice going to the meeting and learning the same time the inspectors are learning the same issue, so that way it can be debated and hopefully come to a consensus agreement.
Yeah,
which is nice.
And I think out of these discussions, as I sit on co-panel 2, and we've always had debates, and we made big changes around how to calculate the number and how to serve peninsulas and islands, right? I mean, it's always debated. And I think we made some great changes. So when we come out with the change, and you sit in these meetings where we're talking about code, and you have the inspectors in the field, you have the installers in the field, and you have a wider audience, those individuals start picking at it. And that generates more public inputs and comments coming down the change. And I think that's an area where the NEC gets a lot of its motivation to make changes and clarify and add clarity.
I don't think the code panels will be out of work.
No time soon. But and the other aspect of it, like the IEI, and I know the International Association of Electrical Inspectors makes a code book reference for code changes. NECA, the National Electrical Contractors Association, they make their book. The Independent Electrical Contractors make their book. The IEEE has technical references and whatnot. But those changes and those discussions only are about like what we're talking about now, some of the big changes on the 2020 code cycle. But there are a lot of other changes that happen, and I think it's there's the networking aspect of all of these organizations that I think helps the industry.
And I would encourage the viewers to not just get one book, but take a look at a few of them, because they're not going to always cover the same changes the same. They may even disagree. And if there is some disagreement, talk to them and try to find out. Maybe there's a way of coming to an agreement on what needs to be changed to make it clear in the code.
And I think that's an interesting point. You know, when you have these different books, they do have various opinions, and you got to kind of make sure you talk and talk to everybody to understand what is actually in the NEC.
Oh yeah, and you never and it's those. We grow as individuals when we disagree with each other. If everybody's shaking their head yes, that's when you guys say, what am I missing? Because the code's not perfect. I always say it's like a fine wine. It gets better with time. So in any case, so we've talked a lot about the 2020 code version. We've talked about a little bit about the what's coming down the pike from the 2023 code cycle and some of the technology. So I think to wrap up this discussion, let's just maybe some closing remarks. And I don't know, David, if you want to.
Sure. I would like to thank Eaton for putting this together. It's been great, and I think webinars are the thing of the future. Not the future, but they're important, because there's a lot of ways to get education, and if someone can call it up on YouTube or the Eaton channel or whatever the case may be, they're going to gain some lot of valuable information. And change is going to happen, and we need to be prepared, and don't just sit back and wait for it. Make it happen yourself. And I would encourage anybody to get involved in the code panel process, or the code process itself, because it's not going to be the best code we always would like it to be, but it's not going to be the case. And there's always room for improvement, for sure.
Yeah, I appreciate Tom, you moderating this. I think this was really well done. I appreciate what Eaton's done. Also, too, if anybody gets a chance to visit the Warrendale Experience Center, it's a pretty neat building, and a lot of neat products in here. And like Dave said, I think we all need to. Things are moving fast. New technologies are coming out every day, and we need to constantly educate ourselves and have discussions about how we do things and how we make people safe, and how we move forward.
Awesome, and I appreciate both of you being here. I think we had I really enjoyed the discussion, and I think we gave the viewers a lot to think about. And like you said, David, hopefully that will prompt them to open that book and start making some public inputs and comments in the future. So. And thanks again for those who joined us today and watched this program. Please remember to check out the portal. There's a lot of information and resources that are available for you there. If not there, please check out eaton.com, and stick around to take the survey at the end, because it's your feedback that helps make these better. And I look forward to seeing you at a future version of our Current Thinking.